All right. Well, the purpose of the last video was to kind of go over all of the material that you've seen over the last couple weeks or months, just briefly, to kind of try to show you how it all connects to what you're working on now. This particular video, I'm just going to try to help you out with this particular assignment that you're working on now, which, if I remember, was lesson 10, I think. It's the one dealing with showing that triangles are similar. Before we get right into the kinds of questions that they're asking on that, let's take a step back and again connect it to some of what I was talking about in the video yesterday and just kind of refresh our minds on what it actually means for triangles to be similar. So remember, we discussed congruent and we discussed similar. Congruent figures are exactly the same shape and exactly the same size. So if you have two triangles that are congruent, you're going to have basically the exact same triangle, right? So for these to be congruent, whatever measure this angle is going to have to be the same as this one. Whatever measure this angle is going to have to be the same as this one. Whatever measure this angle is going to have to be the same as this one. Also, whatever length this side is has to match this one. Whatever length this side is has to match this one. And whatever length this side is has to match this one. Everything has to be the same for those triangles to be congruent. If it is, and this is ABC, and this is DEF, then you can make the statement that triangle ABC is congruent to triangle DEF. Now, when you take geometry in high school, I don't remember if you're going to get to this at all this year in those Eureka lessons, but you'll have to be able to prove that two triangles are congruent. In order to prove that the two triangles are congruent, you don't have to show that all three angles and all three sides are congruent. You'll have to show basically there's different combinations of angles and sides that if you show they're congruent, it ends up being enough where the triangles are then going to have to be congruent. I'm not going to get into that right now, but basically that's something that you're going to have to do in the future. Now, we're not talking about congruent, we're talking about similar. Now, we talked about congruent before we talked about similar a lot yesterday, because remember, if you had a triangle in the coordinate plane, and you translated it. So you slid it like up, down, right, or left. I want you to remember that the triangle you ended up with was a congruent triangle because your figure didn't change in size or shape. All it did was it moved on the coordinate plane. Same thing if you had a triangle and you reflected it. Like if you take this triangle DEF and you just reflect it over so it looks like this, it's still going to be congruent to ABC. I mean, the labeling will be in a slightly different order. It's like this now, but it's still congruent to triangle ABC. It's slightly different in the sense that now when you're talking about what sides correspond to each other, this side now matches with this side, while this side now matches with this side, but they are still congruent. So reflections also result in congruent figures, and remember that rotations, if you turn it, also result in congruent figures. The times where they're not going to be congruent anymore is when you do a dilation. So if you enlarge or you reduce the figure, you're going to end up with a triangle that's the same shape as the original triangle, but it's not going to be the same size. That's what similar triangles are. So when you have two triangles that are similar, they're going to be the same shape, but they won't necessarily be the same size. I say necessarily because technically you have to say that because technically congruent triangles are also similar. Normally they will be different sizes. So let's say we have a triangle like this, and we have a triangle like this. You can clearly tell by looking at these that these aren't congruent triangles, but they might be similar triangles. If they are similar triangles, you know the following things. You know that this angle is going to be congruent to this angle. You know that this angle is going to be congruent to this angle, and you know that this angle is going to be congruent to this angle. For those triangles to be the same shape, the angles must match. If the angles don't match, like if that top angle is wider, like if this top angle here opens up wider like that, then clearly those triangles aren't the same shape anymore. So the three angles must be congruent. The angles are really what you're going to be dealing with in your homework today. Now, there's also information that you need to know about the sides. That's something that we'll discuss in more detail later. When you have proportional triangles, and we did talk about this in the video yesterday, when you have proportional triangles, the sides end up, when you have similar triangles, I got to the next thing. When we have similar triangles, the sides are proportional. So like, for example, if this side is 3 and this side is 12, that's already telling you right there that all three sides of the longer triangle, of the bigger triangle, are going to be 4 times as long as the smaller triangle. So for example, if this side was 2, then you would know already, since these are similar, since we know they're similar already, you would know that you'd have to say, well, 2 times 4 is 8. And if you knew that this was like 1.5, then you'd say, okay, well, what is 1.5 times 4? That's going to be 6. On your homework that you're working on this week, on that Eureka lesson, you're not really getting into the sides. You're really just dealing with this fact right here about the angles. Now you'll notice in that Eureka lesson, they don't just say that you need 3 pairs of angles congruent. They're saying angle, otherwise known as AASimilarity. You don't need to show that all 3 pairs of angles are congruent in order to show that the triangles are similar. There's a reason for that. The reason is that you know that the 3 angles of a triangle add up to 180 degrees. Any triangle. Any triangle you have, the 3 interior angles must add up to 180. So an easier problem that you would have had like well before we started talking about similar triangles is I might have just given you like a triangle and I might have said, okay, this is 75 degrees. This is 40 degrees. Find this angle. And you would have to say, okay, I know that the 3 angles of a triangle, the 3 interior angles of a triangle, add up to 180. So I'm going to say, well, what's 75 plus 40? That's going to be 115. And if the 3 add up to 180, I'm just going to say, well, what's 180 minus 115? And that's 65. Therefore, that angle right there must be 65. This is kind of the key idea for you to get to some of the problems that we're about to look at. Basically, the point of this is that if you can show that 2 pairs of angles are the same, like for example, let's say you have a triangle here, and let's say you have a triangle here, and we're trying to determine, are these triangles similar? Well, for you to prove that, you need to prove that they are the same shape. For them to be the same shape, that means all 3 pairs of angles must be the same. What angle similarity tells you is that you really only need to show that 2 of them are the same. Because, for example, let's say you know that this is 80 and this is 80. Let's say you know that this is 50 and this is 50. Now technically, we haven't shown that all 3 pairs of angles are congruent, But if you already know that this is 80 and this is 50, you can find what the third one is. 80 plus 50 gives us what? 130? And if those add up to 130 and all three have to add up to 180, that means that this is also 50. Well, if you do the math in the other triangle, you're going to notice that the math is exactly the same. And this is going to come out to be 50 as well. And you have now shown that the two triangles are similar. They're similar because all three pairs of angles are congruent. So basically, we didn't even need to do any of that work. Because once you already knew that two pairs of angles were congruent, you already know that the triangles are similar. So what angle-angle similarity is telling you is that if you have two triangles and those two triangles share two angles, then the triangles are similar. They must be the same shape. Because if the first two angles are the same, that means the third angle must be the same, and if all three angles are the same, then those triangles are the same shape. Now they might be different sizes, you don't know. Just based on the angles, you don't know if they're the same size or if they're different sizes, but that doesn't actually matter. If all we're trying to do is prove that they're similar, you don't care if they're the same size or if they're different size. All you care is that they are the same shape. So the way that your homework problems kind of ask you some of these questions. Now, I don't know if you had to solve the first two. I noticed in that Eureka packet that the first two problems were asking you to kind of prove this theory, and they were asking you to prove it using a protractor. I'm not sure if your teacher was going to make you do that, because I don't know if your teacher can assume that you have a protractor or not. I'll go over briefly. I can't really show you how to use a protractor since all I'm doing is sharing my screen with you. But basically, those two problems were a little more complicated than everything else. Basically, what those problems asked you to do is they asked you to draw two triangles where the two angles were the same. So basically, they wanted you to do like this. So you could draw like a bottom side for one triangle here, and then you could do like a smaller one and draw a bottom side for the other triangle right here. And then they wanted you to use the protractor. So pick some sort of angle measure, like let's say 70 degrees. So then make this angle right here 70 and make this angle right here 70. And basically use your protractor to measure it out. So let's say I'm just doing this by hand, I'm just making it up. But let's say you measured it with a protractor and it drew all the way up like that. And then let's say you measured this one with a protractor and you drew it all the way up like that. Notice you had to extend that side because you don't really know where the other side's going to be. All right, well then decide what you want your second angle to be. Maybe you pick, I don't know, 30. Doesn't really matter. Just make sure you pick small enough numbers because remember the three angles of a triangle have to add up to 180. So don't pick like 70 and 200. Otherwise this won't make a triangle. So let's say you decided to make this one 30. So again, you can't do this without a protractor. So let's say you decided to make that 30. So then with your protractor, you measured out a 30-degree angle, and then you use the ruler to just extend that side all the way like that. Then you measured it over here, and you use that ruler to extend that side all the way like that. And you have two triangles. Basically, you can just erase all that extra part that you didn't need. Voila, you have two triangles. What those problems wanted you to do was to prove what I just explained to you. They wanted you to prove that these two triangles are similar. Well, the way you would do that is by measuring the sides. These are the only problems in this homework where you'd really measure the sides. So let's say you measured the bottom side and you got like 10. Let's say that was 10 inches long. And let's say you measured the bottom side over here and that was 5 inches long. Basically, what you just showed here is that the sides of the smaller triangle better be half of the sides of the big triangle in order to show that they are similar. So if you then measured this side and it was 8, then this side better be 4. If you then measured this side and it was 9, then this side better be 4.5. I kind of doubt your teacher wanted you to do this problem because I really expect that it's probably not assumed that you have a protractor at home. But basically, this is what you needed to show. So when you did all of this, like when you measured all this out and you measured each of the sides, then you basically needed to show that the ratio of this to this is always the same. So that means 10 divided by 5 should be the same as 8 divided by 4, which should be the same as 9 divided by 4.5. And since I made up these numbers to make it so that it works, these would be sufficient, of course. I doubt you had to do that, but if you did have to do it, this is what I would expect you to do. Now, I just made up all these numbers, obviously, so these numbers wouldn't be what you'd actually get if you measured it out. But if you actually did this using a protractor and using a ruler, as long as you're careful, it should work out. Your numbers probably won't work out as nice as these numbers I just wrote. Like most likely when you measure the sides of those triangles, they probably will be fractions or decimals. But that's okay. It should still work out that the ratios of the sides end up being the same, or at least very close. Since you're measuring it by hand, it might not be perfect. If you did have to do that problem, I don't know if just showing you that was enough to get through it. Feel free to ask me some more questions and I'll be able to help you through that. My guess is that you probably didn't have to do that problem. The problems that you do have to do are the ones that aren't really dealing with the side lengths at all. They're just dealing with what we just discussed before about angle similarity. Like what we just did here with our imaginary protractor, we basically just proved that angle similarity works. So the kinds of problems you have in your homework, they basically give you two triangles. And they ask you to kind of give an informal proof or an informal explanation of why or why not the triangles are similar. The reason they're asking you to kind of give an informal explanation is because when you move on to geometry in high school, you're going to, depending on which class you take, if you take honors geometry, it often focuses on a lot of proofs. When you do a proof in geometry, it's a lot different than the math that you've been doing so far. All the math that you've been doing so far in life, you kind of just do your math and you show your work. In geometry, not only do you have to do your math and show your work, but you actually have to justify what you're doing in words. So you basically draw like a chart here, and everything on the left ends up being your statements, and everything on the right ends up being the reasons. So basically on the left, you do your math and you might say, oh, okay, one thing is congruent to another thing. But then on the right, you have to write why that's actually true. So you basically explain all of the reasons why you're able to make the statements that you're making. Now, the problems that you have right now don't make you do this. They say just present an informal proof or an informal explanation. So they're basically saying you don't need to make it all formal as a 2-column proof. You just have to basically be able to explain why it's true. All right, so now let's get to the actual kinds of problems. So the kinds of problems you have to solve. They're going to give you two triangles. And they're basically going to ask you, are these triangles similar? And justify your answer. Well, remember what you needed to show. You need to show that two pairs of angles are congruent. If you can show that two pairs of angles are congruent, they are similar. If two pairs of angles are not congruent, they aren't similar. They're not going to be super nice to you and give you all three angles. Like these problems would be incredibly easy if all they did was, okay, this is 100, this is 40, this is 40. This is 100, this is 40, this is 40. Like if they gave you all three like this, it would be really clear, okay, not only do I have two pairs of angles that are congruent, I actually have all three. I know right away that these are similar because all three pairs of angles are congruent. They're not going to be as nice to you. They're only going to give you two for each of them. So let's say I erased Now also they're going to make it a little harder about what two they give you, because I could still make this really easy by just erasing this and erasing this. So the angles that they gave you here were actually corresponding angles. So if you look at this, so let's say that this might be a problem they gave you. I didn't actually check all of them and see if they gave you any easy ones. Let's say we label this A, B, C, E, F, G. Okay, and they could ask you, are these similar? Well, you know they are, because right here, you have one pair of angles that are congruent. Right here, you have a second pair of angles that are congruent. That is sufficient information for you to prove that these are congruent. Now, in terms of explaining it, they just want you to write it out in words. So you could say something like triangle ABC is similar to triangle. Now notice the order of these letters matters. So the left triangle, I called it ABC. I started with the 100-degree angle, then I went to the 40-degree angle, and then I went to the unnamed angle. So that means when I do the second one, I'm going to start with E, I'm going to move to G, and then I'm going to move to F. The order that you give those letters does matter, and remember that right there is the similar symbol. So you can say triangle ABC is similar to triangle EGF. Now you have to explain why. So you could say something like, because you could say the measure of angle A equals the measure of angle E, and the measure of angle B equals the measure of angle G. If you don't want to write measure of angle B equals measure of angle G, you could also write it as angle B is congruent to angle G. So you basically said triangle ABC is congruent to triangle EGF because you've got one pair of congruent angles and you've got another pair of congruent angles. Then you could say something like, therefore, we have AASimilarity. Actually, I spelled that wrong. Similarity. You don't need to give this exact wording. Basically, the way that you need to word it, if you're saying that they're similar, is you need to say that you know that you have two pairs of angles that are congruent. Therefore, you have AA. All right, now it's not always going to be this easy, because right now they gave you those two angles that were already the corresponding angles. Well, they could have made this a little trickier on you. Like, for example, let's take these exact same triangles, but instead of giving you those angles, let's say they didn't give you this. Whoa, no, I deleted too much. Let's say they didn't give you this. Let's say what they gave you was this. So, at a first glance, these don't look similar because you don't know two pairs of angles that are congruent. The thing is, there's two angles in this picture that you don't know at all. So before you're going to decide whether or not they're similar, figure out that third angle. So look at the first triangle and say, okay, if one of those is 100 and one of those is 40, they all have to add up to 180. So that means 100 plus 40 is 140. Subtract that from 180. Therefore, we know that this is 40. Well, in the other triangle, we know two of those angles are 40 degrees. So that adds up to 80. So therefore, this must be 100. So initially, you didn't know that those angles are the same. But now that you figured out your third angle, you do know. So you do have two pairs of congruent angles. Actually, you now have all three pairs of congruent angles, but you only need two. So if you wanted to then give your explanation, you could say, again, you could say something like triangle ABC, and you don't even have to necessarily write it out like a similarity statement, like I'm writing it out. You could just say the triangles are similar because, but the way I'm writing it is triangle ABC is similar to triangle EGF And I'm going to word it slightly different this time. I'm going to say by angle similarity, because I'm just kind of giving you different ways that you could write your answer, because angle A is congruent to angle E and angle B is congruent to angle G. So those are really the same problem. It was just they gave you different things each time. All right, let's look at some more examples. So sometimes they aren't going to be similar. So like sometimes, for example, you'll have a triangle and you'll have another triangle. Don't ever guess just by looking at the picture, because the picture doesn't always like match what they really are. You always go off of the numbers that they give you. Also, let's say, for example, they give you that this is 50 and they give you that this is 60. You might make an assumption here that, oh, well, wait a second, the top angle aren't the same. Therefore, these triangles can't be similar. Well, that's not true. Remember, you can rotate, you can slide, you can flip these triangles around without changing them. Just because the top angles aren't the same, that doesn't mean, like for example, this 60 might not actually match up with that top one. This 60 might match up right here. And that 50 might not match with that. That 50 might actually be here. And really, maybe that third one is what? What would it have to be? It would have to be 70. So just because you see the 50 and the 60 and they're different and they're both on the top, don't assume that they're not the same. So let's do one of these problems like this. Let's say I'm going to change the numbers. Let's say this is 45. Let's say this is 75. Let's say this is 60. And let's say this is 80. So you want to determine whether or not these are similar. Looking at the numbers that we have right now, we don't have anything in common, but let's figure out the third just to be completely sure. So on the left triangle, you have 60 and you have 45. Those add up to 105. When you then try to subtract that from 180, you'll see that that's 75. Oh, well, wait a second. We have a pair of congruent angles. Let's look at our other triangle. You've got an 80 and you've got a 75. Add those up and get what? 155? Take 155 away from 180, and then what do you have there? 25, I think? So you have one pair of congruent angles. That is not enough for them to be similar. You actually know that they're not similar because you see that the other angles are not the same. So if you had a problem like this, you could say the triangles are not similar because they only have one pair of congruent angles. So that would be an example of how you could show your work for one of them where it ends up being no. So basically what you're doing with all of these problems is you're looking at the triangles, you're comparing the angles, and you're trying to see, do they have two pairs at least of congruent angles? If they have two pairs, they are going to have all three. Therefore, they are similar. If they don't have two pairs, then they're not the same shape, and therefore they are not similar. I'm trying to think if there's anything else that I want to show here for that. That's basically everything. Why don't we just do one more example here. I want you to try this one on your own. So pause me when I get to the point where I tell you to pause. I'm going to mark off that with this and that with this. That means those are 90-degree angles. I'm going to say that this angle right here is 47 degrees. I'm going to say right here that this angle is 49 degrees. And I am asking you whether these triangles are similar, and for you to explain in the same way they're asking you in your homework, explain why or why not. And yeah, pause me right here and give this a try. All right, so let's see if you got this right. So right now, you know one pair. You've got this 90 right here, and you've got this 90 right here. If you can find one more pair of congruent angles, then these are going to be similar triangles. If you can't, then they aren't. Now the other pair that you have 47 and you have 49. Those angles aren't congruent, but that doesn't mean that the triangles aren't similar, because you don't know if those two angles are even the corresponding angles that you should be comparing. I mean, the way that these triangles are currently oriented, it kind of looks like, if we had like a line of reflection right here, it kind of looks like this one was just reflected over like that. And if that's the case, this top angle would correspond with this one, while this angle right here would correspond with this one. So really, you need to do a little bit of work to figure out at least one more. Now, if you want to, you could find the third angle of both of these triangles, but really you only have to find the third angle of one of them, because once you find the third angle of one of them, then you can see if you have two pairs of congruent angles or not. It doesn't matter whether we want to find this one right here or we want to find this one right here. Let's go ahead and find angle H. So angle M is 90 degrees. Angle A was 47. If you add those up, you end up with what? 137. You know that the 3 add up to 180, and if you take away 137 from that, did I do that right here? So if you take away 137 from that, you're going to end up with what? 43? So that shows you that this is a 43-degree angle. That is enough for you to say right there that these are not congruent, and therefore the triangles are not similar, because you could say that the triangles are not similar because they only have one pair of congruent angles. Now let's say you went through all that work. Let's change these numbers slightly so this would have worked out. So let's say that I'll keep that 47 the same, but instead of this 49, I'm going to make this 40. Actually, we already know what that is. Basically, what if I had made that 43 instead? So if you did all of this same work, except now this was 43, now you've proven the exact opposite thing. This time, you have proven that these are similar, because now you do have two pairs of congruent angles. So now, if the problem worked out this way, so the last time, the problem that I gave you that you worked on, hopefully the answer that you got was no, and you said they aren't congruent, or they aren't similar, but if the problem worked out this way, you could say yes. You could say, there's a lot of different ways you could word it, like you could just say the triangles are similar, or you could make a similarity statement where you say triangle AMH is similar to triangle. Now we make sure we do it in the same order. We went from the 47 to the 90 to the 43. So then on this one, this is going to be the 47 because it's the one we don't know. So J, there's the 90, K, and there's the 43, L. So you could say they're similar, and you could say they're similar by angle, angle, or you could say angle, angle similarity. And to justify why that is, you could say that angle H is congruent to angle L, and angle M is congruent to angle K. That's pretty much everything. Basically, what you're doing in all of those problems is you're showing that they either are similar or they aren't similar. They are similar if you can show they have at least two angles that have the same measure. They aren't similar if they don't. That's all there is to it. Hopefully this was helpful. If you have any questions, please ask and we will go from there.